So number one, this one is I don't give you any set of information. I don't give you an extra root. So if you see a problem like this on the test and I don't give you a root, then you are going to have to figure out what to do. And so you want to go through the thought process of, okay, I'm looking at this. What is the first thing that I always want to check for? You want to check, is it factorable? You don't want to jump to the P's, Q's method unless if you have to. And on the test, I will tell you which one is the P's and the Q's. I'll say use the rational root theorem. So that way you know everything else should be factorable. So this one is factorable, and it's a 4-term polynomial. And so we need to remember from last semester that 4 terms, the only thing you can do with 4 terms is try to group it, okay? So we can group up this here and this here. And I look, what can I take out from each group? And so the first group, I can take out an x squared, and I'm left with x plus 2. And then in the next group, think forwards a little bit. I'm trying to get x plus 2 in parentheses, so I would want to factor out a negative 9 to get something positive inside the parentheses. So if I factor out a negative 9, then I'm left with another x plus 2 group, right? If I divide negative 9 by both those terms, I get x plus 2. Okay, so I know I did this correct. I know that I have this x plus 2 appearing twice here. So we have x squared minus 9 as what is going to be factored out yet again. And then I have the x plus 2 group. And I know I did this one correctly. This is where a lot of us will stop and where we will miss part of the answer. You do not want to leave it like this. You always want to check, can I keep going? And we can. So this is a difference of squares, what I have highlighted in green. That will appear on the test so many times. You always want to check, do you have a difference of squares? That means, do I see 2 perfect square numbers? And I do. I see a 1 and a 9, and they're being subtracted. So this is the difference of squares. So what we do with that is we take the square root of the first term. So the square root of x squared is x. So that is the first term in my parentheses. Then 1 is a plus, 1 is a minus. And then we take the square root of the second term. Square root of 9 is 3. So x squared minus 9 factors to x plus 3, x minus 3, x plus 2. And now this is your final answer, right? And you could graph this. We could say this is now our 3 odd degree function. It's positive. You have roots at all those places. You could tell me that you're going to cross every single time because we have a multiplicity of 1. So we should be able to be putting all that together now, right? You want your answer to look like that, as many groups as possible. So my roots are negative 3. We have a root at positive 3, and we have a root at negative 2. So that is, you'll see that over and over and over again. You want to check for factorability, check, can you keep going? Can you see a difference of squares? Okay, so then number 2, I like this one as well. This one is a binomial. The only thing that we can do with a binomial is check for a GCF, and then if you have perfect squares left over, then you could do the difference of squares, but they're not always like that. So there's no other option with the binomial. You check for a GCF, and then you ask yourself, do I have a difference of squares? So my GCF here would just be 5x squared. I could take 5 out. I could take an x squared from both groups. So I'm left with x squared minus 4 once I factor out a 5x squared from each group. Now, what's left in parentheses is another difference of squares, right? X squared minus 4. 1 and 4 are perfect squares. I have the minus in between, so I can keep going there. So we have 5x squared still on the outside. This becomes x plus 2, x minus 2. That's what my difference of squares factors. And then I can set each group equal to 0 and solve. So the 5x squared group being set equal to 0. If you want to add a set of parentheses around it, you can. That's fine. It doesn't matter what I do, though. My answer is going to be 0. I'm going to divide by 5. That's still x squared equals 0. I can square root both sides. The square root of 0 is still 0. So that whole group is just a root of 0. Doesn't matter what coefficient I have. Then my next root is negative 2, and my last root is positive 2. And so those would be my answers. So we, again, could kind of go through and answer the questions of, you know, what is its degree? How do we graph this? You could do all of that now that you have it factored, okay? So that's where we're at for the warm-up. There will be many questions on the, I counted 3 times that you're going to see that difference of squares appear in your factoring, okay? So make sure that we are paying attention to that. Now we're going to look at the study guide. that last page of the study guide. And I'll also just do a quick run through of the study guide and kind of preview what's on the test while we're getting this out. So the study guide here, the first 2 pages are all going to be free response just mixed together. It's just going to say do the operation. So you'll see some adding, you'll see some subtracting, you'll see multiplying, dividing, expanding. So expanding, you need to know your triangle. I will not give that to you, so you need to know how to build that. And you need to still remember your exponents, which is the expansion, the binomial expansion. So those first 2 pages, that's all just going to be thrown together in one section. That's the beginning of the test. So it starts out kind of easy. Those should be some easy points there. Just watch yourself, make sure you're not making silly mistakes, okay? So that was like the first quiz. So I maybe look back at that first quiz to see what you did. Then we get into the graphing section. And so I will say that none of the problems on the test are going to look exactly like this. Like, you're not going to see me giving you a function and saying, what is the degree? What is the end behavior? Blah, blah, blah. And sketch. It's not going to look like that, okay? What it's more going to be is it's going to say, hey, given a function or given a picture, what is just the end behavior? That's a question. Or it might say, given this equation here, tell me what are the zeros? That's a question. So I'm kind of breaking it apart, and this is where people always get confused. And I tried to explain this last semester too, that this, if you can do this, you can do the test. But we get caught up in the process of like, well, it wasn't exactly like the study guide. It didn't spell it out for me. The test is not going to spell it out for you. So the study guide is here to help you practice. Can you find the degree? Can you find end behavior? Can you find zeros, multiplicity, and tell me the behavior of a function, right? And then can I ask you just one thing at a time, right? I'm trying to save us time here. I'm not trying to have you do this process 10 times over. That'd take you forever. So that's just a heads up. I'm going to ask you all those things, but like individually. Sometimes you'll be given the graph. Sometimes you won't. So if you're not given a graph, my hint is to make the graph, right? Just like the study guide, make the graph, make a sketch off to the side so you can answer the question. And then if you notice, some of them they are not factored for you already. So that could also appear. You will have some that are factored, some that aren't. So you will have to know that process of the warm-up that we just did, right? So hopefully that helps with you solving, and then you can answer the questions, okay? So that's going to be a majority of the test as well, is answering different questions about your function. You'll just have one rational roots theorem problem. So make sure you show me your work of finding your P's, your Q's, but then you can use your calculator after that. And then 24 and 25. I like this one. This is where I did just take a screenshot of this pretty much and put that on the test. So it's an exact, it's not going to be the exact picture, right? But it's going to be the exact idea. So you'll be given a graph that looks very similar to this. It's not a large graph. It's pretty small, so it's easy to tell where your points are. And you need to tell me what the domain, range, min, max, and what the increasing and decreasing intervals are. I do want to just talk about domain and range one more time, because that's one that we haven't hit as much this unit, but we did it so much last semester. But domain for my polynomials is always going to be all reals, right? Notice my arrows are going forever to the right. They're going forever to the left. So your domain is always all real numbers, okay? So that would be your domain. So that's an easy one, right? You can memorize that. Your range can sometimes be all real numbers. Like looking at 25, notice how my arrows are going opposite directions. I have one arrow going up forever, one arrow going down forever. So in the case of 25, both my domain and range will be all real numbers, okay? So if you have an arrow going up and arrow going down, you're good. You kind of are covered with your domain and range. But what if I have something like 24? What if my arrows are both going up, right? So I know I'm heading towards positive infinity forever, but there should be kind of a lowest point that I hit. And so we have to look at our graph. My arrows go up forever, but where's the lowest that I see this graph exists? Right here. This is the relative minimum, right? Which is why those relatives are sometimes helpful. So this minimum is at -5 on the y-axis. I'm talking about the range. So we can say my range is from -5 to positive infinity. Okay? So that's just a quick review. We've done domain and range so many times, that's not going away. So make sure that we still are remembering how to do that. I'm not going to go over that as much anymore for the rest of the semester. Just know that it's always there, okay? We've covered that a lot. So that can help you with those. Then you should be able to fill out the rest, right? You're increasing, decreasing. So that's going to look just like a problem on the test, okay? And then the last page, I said, well, hold off and we'll do this one together. Cross out 13. I just used this. This was a PDF from Miss Brundage's Chapter 6 review. And so I just wanted to use one page of it, but we're not doing 13. But I liked her other examples. I really liked these down here, 14, 15, and 16. So I just want to look at those. So the instructions say to write a function. So I have to be the one to come up with the equation now, given the graph or given a written description, okay? And so it seems a little bit harder than what it is, but we've been doing this the whole time. So I'm the one that needs to come up with the equation. So I can say how we start that out is by writing f of x equals, or you could say y equals, but I want you to get in the habit of writing f of x equals in function notation. And when we're looking at those polynomial functions, right, we were looking at them in terms of its factors or its roots. So if you identify where does my function cross the x-axis, that can help you kind of put it back into its factored form. So if I know I have a root or a 0 at x equals -2, and I have a root at x equals 3, then we can kind of go in reverse. And we did this a little bit yesterday with that synthetic division problem, where I'm given a root, I can put that back into its factored form. So my factors here are really x plus 2 if I have a root at -2, and x minus 3 if I have a root at 3. So it's just kind of moving it back into the factors. But now we need to worry about the multiplicity, right? That's the behavior. So if I look at x equals -2, what behavior is happening here? What do we see? It's a bounce, right? It's bouncing off that point. So what type of degree should I have there? 2 or even, yeah. And so the instructions say to write it of least degree. So you could tell me 4 or 6. I'm not going to count that wrong, but it's easier just to go with the lowest even number, which is 2, okay? Because if you give me 4, you give me 6, that's fine. It's just try to stick with 2. So then the same thing with 3. So what's happening, what behavior is happening through 3? It's crossing, which is 1, right? So I don't have to even add any multiplicity to x minus 3. And so that's it. We now just want to check, though, is my function positive or is it negative? And so this is a degree 3 problem. So what I'm looking for, if it's positive, I should start low like this and end high. And I do. I start down here, come up, and end going up. So that's that positive slope, right? I'm starting low, I'm ending high. So this is a positive function. So I don't need to change anything. That would be my answer. If I started high and ended low, right, that's going down. So I would need to add a negative in front. All right, so let's try that again. So for number 15, I know you can't really see what the number is. I feel like when I copied it, it lost some of the lines, but this is 2. So on the test, it is very clear where your intercepts are. You don't have to guess. I found good photos. And then this one, though, is 0. So we know we have a root at 0. I have a root at 2. So if I want to start writing this, we can say f of x equals. And I like this example as well because we haven't really done too much of a root at 0. You can just write x. Some people want to do like x plus 0. That's fine. But I recommend just writing it as x, okay? Because x plus 0 or x minus 0, doesn't matter what sign you use, just is x, right? And so then my next group would be x minus 2, okay? So I prefer the bottom way. So if you have a root of 0, just put x, okay? You don't have to put plus or minus 0. That's just kind of overkill, right? We understand that it's just x. Okay, so then I can look at the behaviors now. So through 0, what is happening as we go through 0? What shape is that? Bend. A bend, good, which is what power? 3, yeah. 3 would be the minimum. So if we're trying to write least degree, just keep it at 3. And then you have what happening at 2 here? Cross, which is just 1. So we leave that one alone. And this one, if we look at its total degree, is 4, which is an even function. But what way is this function opening? Down. So what do I need? A negative. Good, good. So hopefully that's kind of coming together, right? Think back to all the quadratic stuff. We said if it's opening down, then we need that negative. It's the same thing here. A quadratic is a polynomial. All those rules still apply, okay? So because we're opening down, we add the negative. If it was opening up, you just leave it alone, okay? And then the last one is even easier. You don't have a picture, but I write in words what's going on. So I tell you that you have a 0 at 3, a 0 at -2, and a 0 at -1. And then I also tell you the multiplicity. So you don't even have to do much looking, you just put it all together. So we can say f of x equals x minus 3, x plus 2, and x plus 1, right? We're taking the opposite signs for my factors. And then I have at x plus 2, it said that was a multiplicity of 2. And then at x plus 1, I had a multiplicity of 3. And that's it, okay? I will specify, like, oh, this is a negative function. You would need to add a negative there, right? But if it's not specified, you just leave it alone. You don't need to put any sort of negative. So that's it. So it looks a little bit more complicated than what it is, but we've been doing this the whole time. And that's about it. So